Our presenters today, we have Chris Peterbaugh. This is kind of an older picture of him, but I think it looks pretty good. He's our project coordinator and variation analyst here at DCS. In addition, I have Brenda Quinlan joining us. She'll be assisting with Q&A and assisting Chris Peterbaugh with any particular questions or issues that might arise. Today's software, we will be showcasing 3DCS Variation Analyst CAA V5 based, which is our CATIA V5 integrated version of 3DCS. Now, all of today's tips will work in all versions of 3DCS, as we will be showing some things that involve an integrated solution. The multi-CAD version does require you to use the Power Pack, the advanced translator, in order to pull in that PMI, FTA, and embedded GD&T. The other packages, as integrated solutions, will be able to use the embedded GD&T directly inside your CAD platform. The agenda today. So I'm going to be sending this out in our chat as well. So that way, if you have questions, you can reference the particular item, especially during the Q&A session at the end. So as you see, we've got 9 tips within 3DCS to help either improve your modeling, make you more efficient, or to speed up your simulation when you decide to run it at the end. In addition to this, we're going to be going over black box methodology at the end. In the follow-up questionnaire after the webinar, please note if you'd like to see more about black box methodology, we'd be happy to schedule a webinar specifically going through how to apply and use black box methodology. Today we're going to be talking more about the purpose of black box methodology and what the setup entails. All right, at this time, I'm going to be passing presenter over to Chris Peterbaugh. See you, no problem.
All right, hello everyone. The first tip of the day that we have here is the fast point. Some of these tips may be familiar to some of you, but hopefully at least a few of them will be new concepts. And definitely feel free to share this amongst coworkers and others, anyone using the software. First one here is the fast point. Point and click creation. I'm going to go ahead and jump into a model. We're going to create some fast points here real quick. So fast point, just go ahead and show you. Under the feature point dialog box here, or feature point button icon, if I go ahead and click on that, right at the top here we have this fast point creation. It's right under the frequently used functionality. Now if I click on this, my point labels do show up here. Let me turn those off real quick. And we'll turn those off. Alright, the labels are off. So what I'm actually going to do is I'm going to quickly create some points along this surface on the top. This is for when you don't have exact IJK and you want to create points very quickly. So I'm going to go ahead and do so. Going to make sure you're in the creation mode. I'm going to click on the part and the points here. You got to make sure we show hide points. So now when I have this dialog, the fast point creation dialog box open, when I go through and when I click, we have DCS. We can create center points, switch direction, DCS points, and as I click, I can add a prefix. I need to close the last dialog box here. So as soon as I click along the surface, we can see points being created. These points are just to quickly create an abundance of points. So I go through here, I could add a prefix here within the dialog box. I can also add center points, and it gives me a list of the points I've created. So it's a real quick way to create points where IJKs, XYZ coordinates are not available, and quickly here I'll make 20 points. So that's the first tip that we have here. Feel free to ask questions in the chat as they arise. So tip number one, again, fast point and click creation. We can create feature points, DCS points, and also when your U and V vectors do not align.
Quick question, can you drag those and move those points?
Move those points and those current points. You have the option if you use the point. If you go through, click the feature point, select the point, select the feature, you could type in a U and V if you'd like, if you knew that information. You could also create here, just based off the point you created, you could move it based off some of the feature point parameters.
Yeah, dragging only works during the creation process. After the fact, you need to use the U and V values, like Chris said.
So that's what we have for fast point. The next tip here that we have is the right-click menu. This is more along the lines for people who like to use the tree more than the icons or more than some of these pull down. So the right-click menu, if I choose a part here, I'll just pick on the rib 2 here since I have it open. So this is kind of what we mean with the right-click tip. We have a lot of options here. We can quickly add a move to this part. We have all of our compliant moves, mechanical moves also here. Also with some icons here to help you identify the move, the tolerance, or the measure. We can also add GD&T here. We can add part notes, model summary. We have a lot of options right here. So it's a real quick way to be able to go through your model and just be able to use the tree without rather clicking through, finding icons, finding the associated drop down, and so on. So we do know that's a popular feature and it's rather newer, so we wanted to pass that tip along. The next tip that we have here today is the points dialog select. This actually is another way to copy points. A lot of us in the past have used the copy data feature. So what I'm actually going to do now is I'm going to go ahead and just pick a part here. I'm going to look at my points. When I open this points dialog box, I have an option here, select. When I hit the select button, I have the option to pick a point from another part. So if I wanted to copy the points from the aft, copy them here, I could copy them exactly from that fast point I just created. So it's asking me add 0.9 to part. Now I can hit yes and hit close. And now I actually have that 0.9 in this point. So again, this tip is to just quickly create points and copy points from one to another. Ben has a question here.
Very simple question came in just to verify. So when I'm selecting a part from the tree, does it highlight that in the graphics window?
So for the, you open up the points here, it won't highlight the part in the window, but it does identify it here at the top of the dialog box.
And for the right click, if I use the right click menu on a part in the tree, will that highlight the part?
It will highlight the part there, yes. So any part that you click through here, as we can see, let me zoom in here a little bit, it does highlight that part as well. So when you get some of those bigger models, just kind of lose track of a little bit, you know, am I on hole 1, hole 2, or part 1, part 2?
Especially if you've got a repeated part multiple times in the model, it can be sometimes difficult to determine which part is which.
Right, such as this one here, we have aft bulkhead 1 to 5. So if you lost track of where you're at, highlights and quickly identifies it. So that's the points dialog select. Again, it's another way to go ahead and just copy data, and it can be definitely beneficial. Our next tip here is the measure generator. This is where we can quickly create a lot of measurements at different points. So I'm going to go ahead and open up our model here, or review our model here, and I'm just going to pick on the points that we've already created, this 9 to 22. These are the fast points I created. So if I look at those parts If I look at the upper skin here, I have all these points on that part. So what I'm going to do is under 3DCS, under MTM, GD&T, we have measure generator, and there's also an icon on the toolbars. I click on this measure generator. This is the measure generator dialog box. The first step would be to select your part here from the button down in the corner here. I select my part. You can click on it in the tree, or you can click on it in the physical CAD. I'm just going to click on it in the tree just to show you. And just to show you here, I'm verifying that all my fast points are in this part. So once you click on it here, you can add multiple parts. Now it says click on part 2. I only want to add this part at this time. I'm going to close that. So now what has actually happened is all of the points, all the points from this part are in this dialog box. So with the measure generator, you can create measures in. So I could create measures in the piece part, or in this case, I'm going to leave the measures in the top level. This right here is the top level in my tree. So if you had piece part measurements, we could put it there. So I can change it and select the part. I'm going to just pick a few of these points here. I'm going to pick 5, 6 points. And the measure type, here we are a little bit limited to nominal point or point to point. I'm going to pick nominal to point and select a few of these. Now I have the option to create measures in X, Y, Z, diameter if it's there, associated vector, or projected on plane. For these ones that I selected, I'm just going to go picking X and Z. And you can also set all the spec limits here. I'm going to leave these ones at upper spec limit 1 and lower spec limit 1. Now, as soon as I hit this add button, now we see the measure list has been filled based off the points I selected and the directions I selected. If I had a couple more here, these ones, we want to look at Y and associated vector, and select a couple and add. So now this measure list has been filled with X and Z on a lot of these, and also the Y and the A for associated vector. As soon as I hit OK, it's just asking if I want these measures to all be created. I'm going to go ahead and hit yes. So now if I look at my measures at the top level, I can see we have 26 measures in here, and these are all the ones that I've just created. If I just open one of these up, we can see the direction's been picked, the point has been filled, the measure type has been filled, and again, spec limits are there. So this is a quick way to create a lot of measures if you are going to be measuring a point to itself or a point to point. So the measure generator, like I said, we use it a lot when creating a lot of measures for point to point and nominal to point.
Could you give me some examples of measurements that you can make with the measure generator that would be helpful?
Oh, it's a great way to make a whole bunch of validation measures, checking particular point variations to see how the variation is stacking up through the model. Okay. Yeah.
Great. So if you need to make a bunch of validation measurements or see how your
yeah, it's set up. You do gap or flush. You can because you can do point to point, or you can just check point to self, and you can check diameters, square the grid directions, associated directions, or projected on plane. So I use it all the time.
Great.
All right. So again, measure generator, we're creating multiple measurements at multiple points. Measure generator is actually used a lot too when we are exporting points and bringing them into QDM. So if you have any questions about Measure Generator or how we use it to be send the points into QDM, send a chat, send us a question, and we'll definitely be able to answer it.
Hey, Chris, do you hit that mute button on your computer?
All right.
Oh, I've
the
got it.
tip that we have here is extracting embedded GD&T. The GD&T, this comes from the CAD, PMI information. So we'll show you this. This is saving time of creating the tolerances in the software. We're actually going to jump into a different model real quick. Some of you may or may not be familiar with this model, but it is one of our commonly used models. So this scenario here is based off of the CAD designer or designer, someone within the company here puts the FT&A on the parts, so you don't have to create the DCS tolerances. So if you get parts that have GD&T already on them, the steps to embed and pull that GD&T into the software is as follows. We have the update model button. If I click on the little drop down here, we have a few different update buttons and deletes. The third button over here, we have an update GD&T. I'm going to go ahead and click on that. And we get a small dialog box here. This dialog is used to choose if we want to extract from, push to, if we want to do all components, parts only, products only. And we also have different things such as replacing the GD&T, kind of if you're refreshing, then we can select the part assembly or view or tree. So once this comes up, I'm going to go ahead and just select the top level. So as soon as I do that here, let me just bring this over and search FDT results. 18 GD&T callouts were extracted successfully. So I'm just going to hit OK. And I'm going to exit this little dialog box that we have here. Now when I look in the tree here, parts, and I look at one, let me just expand all these here. We have a smaller model, so we can look at that. We do now have a GD&T list. I'll expand on that a little bit, just so we can see all of them. So anytime I hover over one of these GD&T callouts, it also highlights the mesh on the parts. So, you know, some of these get to be a little confusing. We got a lot of GD&T, a lot of CAD. So as soon as I hover over one, it quickly highlights that surface as well as the callout. Same with positions. I see some profiles here, profile, positions. So we have a lot of different GD&T callouts. Each one of these here, we have 5 GD&T, 5. So each one here had the datums, and it looks like a surface profile. Now this here, if I double click on one of these, you know, I can mess with the description, and I can update it if the CAD designer or if the GD&T has been updated. So it's a quick way. Instead of adding the DCS tolerances, we can pull the GD&Ts. Again, if you have more questions, definitely chat them in. Looks like Ben has a question.
Just real quick. So the dialog boxes that you're using, are they the same in NX and in Creo for embedded GD&T?
I believe that they're common in NX, Creo, Multicad, and we have better ones in V5, and we are currently working on getting better GUIs for the other platforms for the 7410 release.
Gotcha. So using embedded GD&T is just as simple in NX and in Creo, and I will actually add a video that showcases how to use embedded PMI and NX in the follow-up email. Now with Multicad, we can use embedded GD&T and Multicad as well.
I believe you need the PowerPack license, but yeah, when we bring in CAD data from other platforms that has the PMI, it will get extracted when we create create the HSF files for multicad.
So what Brenda just means there is there are 2 translators you can get for multicad. One works with STEP and IGES, and then the advanced one, the Power Pack, works with your native CAD files and can use embedded GD&T, which is your PMI, your FTA. Now, once I import it, can I modify that GD&T?
Absolutely.
Yep, so you can modify it. Also, sometimes we have a bunch of updates. The CAD guy can update it, send it to you, and you update it, or you have the capability to update it right here.
Right. One last question. So I know we can do feature-based tolerances, right? Feature tolerances and point tolerances. And we can do a combination of the 2.
Absolutely.
Right. So you can use point-based tolerances or feature-based tolerances or modeling methods together, right?
Yeah.
Right. So if some of your CAD has some of this FT&A or PMI on it, some doesn't, it doesn't affect us here. So we definitely have models where we have both of those.
Yeah.
Right.
Let's see. Yeah. If I recall correctly, it varies the tolerances first and then the GD&T. So if you have a feature size tolerance, your GD&T, if it's got bonus, will actually pick it up.
Nice.
Unless it's vice versa. So check first.
All right.
All right, so that's what we have for the extracting embedded GD&T PMI. So this is just a picture of the dialog box in CATIA. Again, same with all these tips. They can be done across all platforms. The next one we have here is the process capability database. This is an organized data of different processes and tolerance. I'm going to go ahead and jump back to the other model here. I'm going to go ahead and just view a few of these tolerances. If I look under the tolerances here, I'm going to open up one. A lot of you have seen and maybe been a little confused on what this link to database actually is. So that's what we're going to talk about here in the next few minutes. If I click on the link to database, we see here we have aluminum machine surface. If I click on this button, the database that I created, just a default one here, we have a bunch of different features that we can add. So if I knew that was aluminum machine surface, I can easily just change this to a steel machine surface, and now it not only updates the name here, but it will update the range as you go. So you could kind of just go through, change some of the materials. We have a lot of filters in the database, point, surface, pin, hole, slots. In the database here, let me expand it a little bit. So there is a lot of information here. We're not going to exactly walk through all of it at this time, but it does give you the name, range, any offsets, random types, sigma number, skewness, kurtosis, and more. So in order to build one of these or get one of these, again, we also have material filters. We can add to these material filters, and the same with the process filters. This can be added to. I'm going to go ahead and just show you how we import that database. So under 3DCS, we have the data, we have process capability database. This is where we go ahead and just pull the database file location. At this time here, this is the location. Let me go back one here. Let me grab the DCS. So we have one here. Let me just see if I can open this and show you it in Excel real quick. So this is created in Excel. Let me just expand a few columns, expand a few things, and talk about it a little bit more. So we have our column here. We have some information that reads right into the software, but we have the names, and we have the tolerances, we have the random numbers, the offsets. All this information is put into here. So I have the capability that I can change a bunch of these positions. I can change a bunch. I can save a new database, and I can import the new database. With the new database, I could go ahead, import this database. Going to open. As soon as we choose that, we have this load database and show link info button. It shows me here which ones are inconsistent and same. I don't have any under my inconsistent. I didn't lose any links, and I have some the same. So when I click on this link here to update model, it updated 3 of them. I'm going to go ahead and hit OK, and now I can open this up, and I did change a little bit here with the range. And the link, again, I could choose one. I could use the database to run different scenarios, maybe different plants. They're trying a new position tolerance on a few different plastics. You could have multiple databases and run the simulation to compare. So instead of going through and changing 10 tolerances at once, 20 tolerances, or as many as you want, you could change them all at the same time if they are linked.
It's also a good way to standardize your tolerances across your different modelers so that everyone's pulling the same tolerances for the same processes. So if you've got 5 or 6 different people that are modeling for you, you can make sure that they're all using similar tolerances on the same kinds of parts or the same kinds of processes.
Right. So we also have people using, they create the next model, the next year version. They can just use the last year's database, make a few tweaks to it, based off what they saw in the plant, based off some of the CMM data they've seen. They can make some changes to that database, bring in that new database, and run some results and get some diagnosis. And again, if you have any questions about the process capability database, send us a chat or send us a question. Moving along here, the next tip that we have is the tolerance wizard. This is, again, an icon, an option in all softwares. In CATIA, it's actually a user DLL. In the multi-CAD, there is an actual icon within multi-CAD. So this one it is a little bit different across platforms, but it is available. When I open my user DLL, you may or may not have to add it already here. The DLL we're looking for is the DCU Tile Wizard. Can be found under your extra DLLs. DCU Tile Wizard. Since I already have it open here, I'm just going to click on it and run function. Simu worst case. Let me go ahead and once you have the Tile Wizard, we want to go ahead and pick the Tile Wizard from the function name. Once I hit that run function, we see a tree here. I'm going to expand this tree a little bit. So this tree, what it does is it mimics your DCS tree. And we have the part. Let me just minimize here a little bit. So we have the parts, we have the features. Now I see under each feature we have the points, and the points are color-coded. The color coding here we can talk about in 1 second, but one thing to point out first is we have the point name. We have MV, which is a move, so this point is in 1 move. Measure, this point is in 0 measures. We have the GT equals 1 and the TL 0. So this point is used here in the move and then the GD&T as well. So if I expand that again a little bit more, I can actually see the move and the GD&T in which this point is located. So just to loop back around real quick, the color coding, you can go ahead and you can hit, just to walk through, there's a help button. Sometimes we'll forget what some of it is, so we always have the help button. Just gives you a little description, and let me highlight it here for us. The green identifies that the feature's toleranced and used in the operations or measures. The red means it's not toleranced, but it is used in the operations or measures. And the yellow, it means it is toleranced, but it's not used in the operations or measures. So we can quickly use this tolerance wizard to identify which points are toleranced, but not in a move or measure. We can also use this tool here to verify that all features that are important to moves are toleranced. So it's a real quick check instead of expanding the tree, going through, doing point information on certain points. We like to use it as a quick reference, just in a color code matter. So we have a few filters here that I can hide tolerance features. We can hide the not used features. We can hide move tolerance measures. So it is a little customizable, and we have a long summary here that kind of gives you the same thing, just not in a color code format. So again, the tolerance wizard, color coded format, identifies, if the points are used, if they're toleranced, and if you have questions about the colors, again, we do have this help function that identifies it.
So this, like the measure generator, is a really good tool to use for validating your model and double checking your work. Because as we all know, when you're going through some of these models, sometimes you forget points, or you might make a small error, or something might not be set up optimally. So these are nice validation tools that you can quickly check before running your simulations to verify that your simulation results are going to be accurate.
Yep, that's a good summary there. So now we'll move on to our next tip. The next tip is the MTM info. This tool right here, this tip right here, it's very helpful for debugging moves. So let me go ahead and just show you this. Under 3DCS, MTM, GD&T, we have the MTM info. Click on part 1. I'm just going to go ahead and click on the top assembly so I get everything, but you can click on sub-assemblies to help identify. This is the MTM information dialog box. I'm going to expand it a little bit. Real quick, you can choose move, tolerance, measure, GD&T. I'm going to go ahead and start with the move. So what this is doing right now is it's listing our 16 moves. If I click on show point coordinates, we can see here that move 1, or whichever move we have selected, just below here, it will show the point name, the part, and the actual XYZ coordinate. So we can use this to identify verifying coordinates XYZs are correct. Just click through here real quick. It identifies the point as O1 and T1 in the move as well. For something like a 3-point move, it will just have the O1 through O3. We also have the show coordinate differences. So what we have here is we have O1, T1 difference, O2, T2, and difference. I can turn off the point coordinates, and we see here this move, we have no differences. So if you're having a problem with a move, I've actually kind of tweaked one here to show us. So visually, I have a point, I have a part, it's not moving correctly. Now I'm able to use the MTM info to see the difference in point 4, 5, and 6. It's shifting in X by 1.524 millimeters. So now we can kind of go in, dig, look at the point, see if we mistyped a coordinate, to see maybe if we even picked the wrong point. So I go through some of these. We have all zeros. Our points are overlaying each other very nicely. We have one here, another one, difference. We do have some X, Y, and Z. So again, we use this to help debug the model, debug some moves. If parts are shifting on your move the wrong direction, this is just kind of where we can help. This is where we start debugging. We also have the same for tolerances, a little more in depth here. Measures, we can show the current, nominal, and spec limits. So this is a big table used to kind of give you a summary of everything in your model. And again, we also have the summary button here in the corner, the same summary that is in the Move dialog box. Kind of gives you just some general information, point names, XYZs, IJKs, and more. Floats, move parts. So that's what we have, a little summary there on our MTM info dialog box. Just moving along here. We always get this question here, simulation times are taking too long. So we have a few tips here. The first one here, unchecked detailed HLM GF, geofactor. Just a quick abbreviation that we've used here. So we'll go ahead and I'll show you where that option is and talk to you a little bit about it in the software. If we go to our DCS preferences, we have it right in the general tab. We have a detailed HLM geofactor button. So we can easily turn that on or off. If I hover over it, it does give us a little description. So with this on, what it's going to do, it's going to consider each mesh point independently during the sensitivity. So if you have some really dense mesh with this on, the model will be scanning every single mesh point. So we definitely recommend turning that off if simulation speed is definitely hindering you. By default, it is off. So it is something that you may have never even turned on. But again, we just wanted to point that out and help you save some time on running some simulations. And again, minimizing mesh on the feature measures. The feature measures, we can use this min segment, which controls the mesh density. A larger number will create finer mesh. So in this case, the more fine the mesh, the more computation time you're going to have. So again, it's another tip just to get your simulation time a little bit shorter. The next part of it here is to limit iteration and conditional logic. This model actually doesn't have any of the iteration and conditional logic. But as you can imagine, if you're putting in conditional logic, if you're moving the skin and it hits a certain part, you're having logic to move the skin until it hits a surface, again, that's added computation time. We understand that sometimes you do have to have some of those, but if you can, possibly limit the amounts of those.
Quick question on the HLM geofactor, the detailed HLM geofactor. If you turn that off, now using feature measures, how does that affect the accuracy of your model?
Because the feature measure in that case is going to be non-linear, it could make it more accurate or less accurate. You're in a situation where, you're trying, the high-low mean is trying to treat each of those feature nodes as a separate contributor, but the feature measure is trying to find that minimum gap. So the tolerances are interacting. So both cases are going to give you an indication of what it is. But it's like trying to take a 3D universe and flatten it into a 2D perspective. Depending on which direction you flatten or which that 3D universe into a 2D plane, you're going to lose something. You're going to lose a dimension.
Is this something that simulation-based sensitivity is addressing?
It is indeed.
All right. So we actually are building a tool which is coming out very soon, and we'll be doing our next webinar on it called Simulation-Based Sensitivity, which will help address some of these feature measures and some of the issues with 3D versus 2D interaction.
So just jumping back here, again, limit the iterations and conditional logic. The last one here is called model washing. It actually removes points and MTMs not used in the model. Before doing this step, we definitely recommend that you save your model, just due to the fact that we don't want you to lose your precious work. So under Update Model, we have a Delete Unused Information icon. I'm going to go ahead and click this. We have a small dialog box here. It's asking us again to select a part or assembly in the tree. Deleting will start upon tree selection. So we have a couple options here. We can delete all unused geometry, which we refer to as washing. We can delete unused points and features, and we can delete duplicate CAD entities. I'm going to go ahead and do this washing function and click on my top level. And so what it's done here, it provides a list of everything that is actually washed. So these are all the surfaces that have been washed, all the points that have been washed. These could be, if you're moving around points, you made a few extra points in your move on accident, but you never went through and deleted them. A few extra points for a tolerance, but you're not using it in a move or measure. So now what we've actually done is just cleared it out. So by washing your model, it has created less information in the model. And again, we definitely recommend save before doing something like that. Looks like our last tip of the day that we have here is the black box methodology. So we have just a few slides on it. We don't have a model for it. Just a few pictures just to try to help you out here. Black box model. So we have a few different graphs here. Black box modeling here. We have part 1, part 2, creating a sub-assembly. Part 3, creating one giant assembly. So what we actually do, we're going to break this structure down into how we might 3DCS model structure this. So this sub-assembly, part 1, part 2, we are actually going to work on this model separate. Could be a separate person, a separate part of the company, someone else doing this model even. And what they can do is they can build this model and send it to you, send it to another model, and we consider that a black box. We have the black box in juncture with another part or sub-assembly, creating one large assembly. So we have a little bit more detailed on this. This one we could have its own webinar if we have enough interest in it, or we can answer questions as they come in. So again, it's just the black box model. It's just avoiding the very large models. We're pretty much segmenting and slicing up the model into smaller models. Just a few advantages, disadvantages. I'm not going to read here PowerPoint word for word, but the advantages are the big models. We can use MTMs, replace that with some of the points and tolerances. Final results, they can be used for just reporting out. We don't have to report all the smaller segmented model results. If you say you're building up, an airplane, maybe just not the wing, you want to look at the results of the whole thing. There's a lot of different scenarios, a lot of different ways people are using the black box, but there's also a few disadvantages. Some of the sensitivity, some of the contributors of the smaller models will not show up in the larger models. So again, too, with more models, you're having more data, more CAD, just more management in regards to data. So again, that can always get a little bit tricky when you're working with multiple people, multiple different, parts of the company. So just a real quick, the black box, we like to use one of our DLLs, the DCU CMM Dev. We're using this. You can also use this to import CMM data, but we actually use this DLL to bring in points from other models. And pretty much just a quick conclusion of the black box. we're using a DLL to bring in points from segmented models, and also just it's a good way to divide up the models, bring in points using a DLL. Just again, some of the contributors from segmented models kind of get lost a little bit, but if you're looking for the end result of how your complete model is going to look in regards to build, in regards to how some of the statistics will end up showing, this is where we kind of suggest, and this is where we assist here in the black box. So I think that's it. That's all we got for the tips portion. I know we do have some questions coming in. Looks like starting with Ben.
Well, first off, I want to thank Embraer for letting us use some of their black box methodology information from the DCS conference. Since I've got Brenda here, Brenda, could you give us an example of when you've used black box methodology?
Yeah, we recently used it on a vehicle line where one modeler built up the body in white and another modeler built up the final line and used a black box body in white. So instead of having, the hundreds of parts and tolerances, they had one solid assembly as the body in white with the black box tolerances to make the model run much faster.
Great. All right, well, thank you very much, Brenda. I appreciate it. We do have a couple questions I want to get to. So let's start from one or two from an earlier part of the webinar. So on FastPoint, on the sample surface, how does it identify which features will be picked on the surface? So when you're making your points.
Which, can you say that? Repeat that one more time.
Sure.
Oh, you got to hover over the surface.
So you're selecting the specific surface for the fast points?
Yeah.
So as I hover over different surfaces, it does highlight it. So it's helping identify which surface. We know how surfaces, at times here we can't always just click on them and see the whole thing. We might see a corner or something. We want to add a few. So whatever surface is kind of highlighted as I go through and pick it at fast point. So whatever surface here is lit up, highlighted, selected, that's where it's just kind of identifying it.
Great. And then with the measure generator, can you just bring up the measure generator really fast? Just the dialog box.
Yep.
And show again where you select the specific type of measure.
So we have measure type here at the list. Measure generator, it is only limited to nominal point and point to point at this time. But again, if you're creating a lot of different measures, this is also where you can put the spec limits on all of them if you wanted to, instead of going into each dialog box.
So you're going to set your measure type before creating the measures. And with measure generator, there are only two measure types you can use with it.
Yeah, you have to select the type before you select the points.
Right. As we see here, if I select a different one, just kind of goes away and we have to select the part. So nominal point, and then I select the different ones and choose the directions. We also have some feet we can remove. If we added too many, we have remove, we have clear, we have some options there.
All right. So quick question about process capability database. So linking tolerance to the process capability database. When I know I can do that when I create the tolerance. Is there another method to do it?
You mean through like Excel linking or find replace or something?
So if I have 100 tolerances on a model that I've received, or I've imported my embedded GD&T, and now I want to link those to a process capability database.
I'm sure there is, and what we should do is have Jason or one of our tech support people make a post about it on the community website.
Great. All right, no problem. So I'll look into that and see if we can't do a follow-up with our email on that. Next one. So as a reminder, we are going through different methods to improve your simulation times. These are tips during modeling. We actually have a webinar dedicated specifically to 2 new enhancements that are going to vastly improve simulation speeds. So you can use today's tips to make your model faster in simulations by streamlining it or some of the settings you do. We also, on September 28th, are having a webinar on 2 new performance enhancements, our multi-core processing and a new cloud-based processing, which will allow you to use multiple cores on the cloud to run your simulations. And you can see speed increases of 10, 20, 30%, or sometimes a couple 100%, depending on how you have your model set up and how many cores you want to utilize. So if you're still seeing large simulation times, even if you use some of these modeling tips, or if you're not able to use these modeling tips, please make sure to join us on September 28th to see some other options you have coming up to vastly improve your simulation speeds. Okay, I'm going to check to see if we have any more questions that we haven't gotten to yet. I do want to make a note here. Someone asked about using JT files. So if you've got your PMI in a JT file and you want to use that with multicad, we actually, because of the JT file format ownership, we have a separate JT translator that is separate from the 2 standard translators and is specific to JT. It's, I believe it's very inexpensive, but we do have a separate translator specifically for JT files for multicad. And that just has to do with the way the licensing is set up. Now, when we're linking the process capability database, we can use feature tolerances. Is that correct? Can we also use point tolerances?
Mm-hmm. Yep.
So you can link either kind of tolerance, feature-based or point-based, to your process capability database.
Do we have a GD&T dialog we can open?
Nope.
Okay.
I don't have.
Yeah, probably not on this model.
Yeah, I don't have one on this.
Yeah, I don't remember if it's also available with the GD&T or not.
Well, I'm not positive on that one.
Yeah, but it is available with every type of tolerance.
Okay, so you can link any kind of tolerance in your model to the process capability database.
Yeah, it can be here. I'll just show you here. A circular featured user DLL. You know, if we're creating a position, circular tolerance, we have that. If it's a whole pin, we have that. So we have it on every single one here. We have a link to database. So if all your pins, all your fixture pins are the same size, this is where the database comes in very handy.
Great, thank you. Just want to check real quick to see if we have any other questions. Way detail. Okay, here we go. This is a good question. So the process capability database, can I put it on a server somewhere so a group can use one file?
Absolutely. And it is available in GD&T, at least in the multi-core multi-CAD platform.
Okay. So yes, so you can, so if you have access to your network, you can put a shared database on your network that multiple modelers can use and call from. So if you've got one set of tolerances you want everybody to use, that could be a good way to control your revisions.
Right, revisions and also different ones. You know, if we want to try a simulation with some different values, we can go through, change some of these values, make some ones, and we could save it as a new one, just a save as database, you know, 2017 version. We can import that into our model and run it again. So we can quickly create multiple databases, multiple scenarios.
Right, and when you do change the database, you do have to re-upload the database to your model in order to update your model.
Yep, so when you do that, all you have to do is back into the data capability database, and we just choose the new one. I didn't save a new one here at this time, but we would just click on the secondary one, load database, update model.
So it is not dynamically linked. And that can be important too, especially if you're sharing it with multiple colleagues, or if something happens to your database file itself, or if you lose connection to it. So that allows you also to have multiple databases available. So if you've got, as Chris mentioned, if you've got different variations on your specific design intent, or if you've got different suppliers that hold to different tolerances, you can create different databases, each representing a different set of tolerances. And then by uploading different databases, you can quickly change all of your tolerances to new scenarios.
Yeah, this comes up a lot in modeling in general, where you want to have different scenarios or different variants of the same model. And we're working on a more comprehensive solution. Not sure which version that's scheduled for. So to be able to have what-ifs saved that give you new sets of moves, tolerances, and measures. But for the moment, this is a easy way of having tolerance variants saved and saved in an outside file that can be copied and emailed and
Gotcha.
Generally shared.
So here's a quick question for you. So say I'm using the process capability database, and I've started applying it to tolerances within my model. How do I determine which tolerances are linked to the database and which ones are not?
It's somewhere. I'm sorry.
So there is a method to determine that.
So just if you have a question about a certain tolerance, I mean, you can open it up and you can see the name here. But that's if you want to go through, a couple individually. In a summary version, that one's slipping my mind right now.
It was in the toolbars, but now that we have new toolbars, I can,
So there is a method to do it.
Yeah, add that
no
to
problem.
the blog.
So well, there's a couple of these questions. I'm going to follow up with some of the rest of my team and add them to the follow-up email you'll be receiving tomorrow. Just because sometimes on the spot, we're not sure on every specific detail.
Well, I haven't used it in 6 months, so.
You've been doing development work.
Yeah. All I've been doing is sensitivity work, so.
Right.
And best fitting routines.
No problem. Sure. So here's a good question. Now, with the software, we provide a template for the process capability database. How do I find that template? Is that automatically within the process capability database? Export?
I would look in the example files that come in the help files. That's the first place I would look, Ben. But yeah, we...
No problem.
These
So
are great questions.
Yep.
But I didn't look it over ahead of time.
Sample database. Great. So what I'll do is I'll add that to our follow-up email because that's an important question for those who are just getting started with a process capability database. Because we do provide an example, and that allows you to get started with the formatting and some example tolerances that you can then add and modify. And I know Jason has showed this to us in a previous webinar, so I'll ask Jason, and he'll know right off the bat. No problem. And then I'll add that in the follow-up email. So we do have a follow-up email that you'll be receiving tomorrow. We did mention this earlier in some of the sign-up that will have the recording of this session. I'm going to be adding some of our other tips and tactics webinars as well to that email with some agendas on those webinars, so you can see exactly what tips those include. I know on one of those that we had Jason do, he went into additional detail in the process capability database that can be helpful. And I will also have the answers to some of these questions as we look into them a little deeper. We are at 12:03, so we're a little past the top of the hour. So, yep, so we will be closing this down. If you have additional questions, please either add them to your questionnaire at the end, send me an email, or reply to the email that you receive tomorrow with the recordings, and I'd be happy to assist you. So I want to thank everyone once again for joining us today. I really appreciate all of your attendance. I hope you found this valuable, and I look forward to seeing you in August at our simulation-based sensitivity webinar, which will showcase a new feature we have coming for 3DCS. Please go ahead.
Yeah, if you're on the beta tester list, a very rudimentary version of it is included in Beta I.
Beta I. Fantastic. So if you want to start taking a look, in fact, I'll include some information about this simulation-based sensitivity in the follow-up email, so you can take a look at it and see what it is that we're developing and working on for you. And I'll also include a little information about our upcoming performance enhancements to our software, which will give you an enormous speed increase in your simulations. So once again, thank you all for joining us today. I appreciate it. It's been really great having all of the questions and having all of the feedback. So once again, please fill out that questionnaire when you leave the webinar, and we will see you in a short month.
Looking forward to it.